from the tail of P and it is going to terminate at the head of Q. This would be the resultant. So the direction, if you understand, is taken in the reverse order. So now you are finding that the direction of vector R, P and Q are in the same order, that is, they are almost directed towards positive x-axis, or they are in the first quadrant to be precise. So here the vector R bar will be summation of P bar plus Q bar. And as per triangle law of vectors, what we do is, instead of taking the R bar like this, the direction of R bar will be reversed. Let me show you it. So here the R bar will be reversed. This is how the R bar would be. Now summation of R bar plus P bar plus Q bar is equal to 0. So here the equation, how it was transformed, means once we have modified the direction of R bar as per this becomes minus R bar equal to P bar plus Q bar. So now the R bar is shifted to other side along with P and Q. So in the closed polygon, the summation of vectors is equal to 0. So the same concept is also extended in the polygon law of vectors. You will be dealing with more than 2 vectors, or it could be combination of 4, 5 or 6 vectors, and the 7th vector is going to be the resultant of all those other 5 or 6 vectors. Next is the resolution of force. A single force is, if it is replaced by 2 or more forces which produces the same effect, is called resolution of force. So resolution of force, let's say that here this is x and y axis, and at a point, let's say this is point O. At point O, there is a force acting at point O. Let's say this is F, and the force could be making an angle of theta. Now, instead of writing F at an angle of theta, what I'll do is, I will be replacing F with 2 other forces, and those 2 forces will be producing the same effect that is being produced by the single force F itself. So here the theta is marked with respect to horizontal. So the horizontal will there will always be cosine adjacent to the theta angle marking. That is, the horizontal will be having the cosine as a trigonometric ratio. So the x component or the horizontal component will be fx, that is equal to f cos theta, and the vertical component, that is fy, is equal to f sin theta. It could be same way. The force could also be resolved in 3-dimensional plane, and that is the extension of the resolution, where the problem is going to have more complexity. So at this level, we will try to only understand the resolution of force only in the xy plane. Next is the laws of friction, dynamic friction. So dynamic friction, it is always less than the limiting static friction. So this is the first law, that is mu k, that is kinetic friction, is always less than the static friction, because the resistance is reduced as the body is set into motion, and static friction will be much more. Reason is that the resistance will be dominating and the body will be at rest only. Next is the dynamic friction is proportional to normal reaction. The dynamic frictional force is proportional to normal reaction, and it is independent of area of contact between the 2 surfaces, and it remains constant and independent of the sliding velocities within the limits. So these are the laws of dynamic friction. Angle of repose is the maximum angle of an inclined plane with horizontal at which the body is just beginning to slide on its own due to the weight. So here, if I draw the diagram, let's say the angle of repose is phi, and on it the block has been placed. So let's say this is the block that has been placed on the inclined plane. and the block is tending to slide on its own, or the motion of the block is impending, I should say. The motion of the block is about to start. It's not started actually. And when the motion is impending, then that is called as angle of repose. So here, that is the angle phi, or tangent of phi, that is equal to mu. This is the relation. Mu is the coefficient of friction and phi is the angle of repose. So the angle that is going to tell us for which the motion of the block is impending, and the motion is only caused by the weight of the block or component of the weight. The question says about a block whose mass is 5 kg and it is resting on the horizontal surface. Coefficient of friction is 0.3 and 18 Newton force is applied on the block, and the friction force exerted on the block is to be determined. And if the block will move, whether the block will move or not, even that is also to be determined. So first is that let's calculate the weight of the block. Weight of the block, that is W, is equal to M into G. It is, that is 5 into 9.81 newtons. Next is coefficient of friction is 0.3 and applied force is 18 newtons. So first is, we start with the free body diagram. So in the free body diagram, let me just mark the forces. So there will be weight of the block that is going to act downwards, and along with the weight there will also be another force that is countering weight, that is normal reaction. Let me draw the weight as well as the normal reaction. This will be the weight. Next is the force of 18 Newton is applied on the right side, and the same force will be countered by the friction force in the left side. So friction is always going to oppose the motion. So this would be Rn, and this is W, and this would be P, and here this would be the friction force. So now if we estimate the friction force, that is, first is we begin with equilibrium of forces in the y direction, that is Rn minus W is equal to 0. So Rn is equal to, that is 5 into 9.81, which is 5, and 8 5s is 40, so this is 0, and this is 5 9s is 45, so this would be 49. So Rn value is 49.05. Next is the friction force, that is friction force is given by mu times of Rn, which is 0.3 into 49.05. So this is equal to 14.715 newtons. So friction force is lesser than the applied force. So P is greater than F. So the block will be set into motion. And if this coefficient of friction 0.3, if this was static friction, then this will be replaced with kinetic friction when the block is set into motion. So as per the calculations, we are finding that P is greater than F. So which means the block will be acquiring acceleration. The question says about a block whose weight is 100 Newton and it is placed on an inclined plane with an angle of 30 degrees. If the coefficient of static friction between the block and the plane is 0.4, determine whether the block will start sliding down the plane or not. So first let me just draw the inclined plane. Let's say this is the inclined plane, and let me draw the horizontal as well. So on this inclined plane, we are finding a block that is resting. So let's say this is the block given, and now here the angle made by the inclined plane is 30 degrees, and here the components of weight that will be acting along the inclined plane and normal to the inclined plane. And let me just draw the components of weight that are acting along the inclined plane and normal to the inclined plane. So these will be the components of weight. And next is the weight is going to be vertically downwards. This would be the weight that is going to act vertically downwards. Let's say this is W. And if you try to compute the angle here, this is 90 degrees with the horizontal. And here it is forming a right angle triangle. So this is going to be 60 degrees, and same way the angle here will be 60 degrees, and the angle with on the left hand side, that is with normal component of weight with vertical, will be 30 degrees. So this becomes W cos 30 degrees, and this would be W sin 30 degrees. Now there will be one more force as the surface is rough. So one more force which is going to resist the motion of the block along the plane, and that is friction force. Let me just align it, and let me just change the color of this force. So this will be the friction force, and which is going to be resisting. So this is F. Let's say it is F. So now if we go for equilibrium of the forces, that is summation of forces in y direction, along with the friction force, there will be another force, that is normal reaction will also be there. So let me just add that one as well. This would be normal reaction, that is Rn. Now equilibrium of forces in y direction, that is Rn is equal to W cos 30 degrees, which is 100 into cos 30 is root 3 by 2, which is 50 root 3. 50 root 3, that is 50 root 3 newtons it is. Next is the equilibrium of forces in the x direction, that is equal to 0. So the component of weight, that is W sin theta, is going to be against the frictional force, that is equal to 0. So W is 100 sin 30 degrees minus F. F is mu times of Rn. So F is mu times of Rn, which is mu is 0.4. So 0.4 into 50 into root 3 by 2. This is equal to 0.4 into 50 is 20. 20 root 3 it is. So this is 10 sin 100 sin 30 minus 20 root 3 it is. 20 root 3. So let's check whether this is equal to 0 or not. So 20 root 3 is approximately 34. Let me just check. 34.64. So friction force, we are finding that the friction force is greater than the component of weight, that is W sin theta, sin 30 degrees. So which means that the friction force is holding the block from sliding. Friction force is holding the block from sliding. So here the block is going to be stationary. Block will not slide. Block will not slide along the plane. In the question, it says about a weight 5 kilonewton, which is supported by the help of two strings as shown in the figure, and the tensions in the strings is to be determined. So let me just give you a very important insight about the problem. So here you are finding the three forces, that is T1, T2, and the another one is the weight of the block. So when here there are three forces. So whenever you find a three forces, those are concurrent, passing through a single point, then Lami's theorem is applicable over here. And let's say if this is the point O, so the forces T1, T2 and W should be taken in a way that they are directed away from O, or they should be directing towards O. And then only you can apply Lami's theorem. Otherwise, there will be a error in the sign of there will be error through sign, that is negative sign will be reflected in the answer. So that is not completely wrong, but ensure that you know the proper usage of the Lami's theorem and what representation of forces is needed. Even that also matters. So now to begin with, here at the point O, there are three forces, and it is just that we need to compute the angles. So T1 is making an angle of 60 degrees with horizontal. So the angle included with the weight becomes 150 degrees, and T2 is making an angle of 45 degrees. So with weight, the angle comes out to be as 135. So this is 135 plus 150, which is equal to 285. So 285, that is 360 minus 285 will be equal to, that is 75, would be the angle included between T1 and T2. So now if we apply the Lami's theorem, so T2 should be divided by the sine of the angle which is opposite to T2. That is, the angle should be on the opposite side of T2, that is 150. T2 by sine 150 equal to T1 by sine of 135, and the weight is 100 newtons, sorry, it is 5 kilonewtons, that is 5000 newtons, divided by sine 75. So T1 will be equal to 5000 into sine 135 divided by sine 75 it is. Next is T2 equal to 5000 into sine 150 divided by sine 75. So you can do the calculation for these. Let me just check it. 5176.380 into sine 135, and this would be 5176.380 into sine 150. So this is into sine 135, that is 0.707. This is approximately equal to 3659.701 newtons, and this is approximately 2588.190 newtons. And the angle between the two forces is taken as 60 degrees. The magnitude and the direction of resultant is to be determined. So let's begin by keeping the 50 Newton force as horizontal and the other force, that is 25 Newton, let's say it is making an angle of 60 degrees with the horizontal force 50 newtons. So the resultant is going to pass through from the intersection of these two forces, and let me just change the color of the resultant, and the angle will not be the same. And here I would like to indicate one more information. As we are able to find the 50 Newton force is more than 25 Newton force, so the resultant will be having more closeness. Resultant will be having more closeness to the 50 Newton force, and that can be also understood from the formula. Let's begin the solving. So here let's say P is the force which is 50 newtons, and Q is another force that is 25 newtons, and straightforward we need to make use of parallelogram law of vectors, that is R is equal to root over P square plus Q square plus 2PQ cos theta it is, and this is kept within the root. So R will be equal to root over, this is 50 square plus 25 square. So 50 square is 2500 and 25 square is 625, and 2 into P is 50 into 25, Q is 25 into cos 60, which is 1 by 2. So upon solving, we would be getting R as equal to root over 4375, or which is approximately 66.143 newtons. Now, if we try to calculate the angle between the resultant force and 50 Newton force, let's call it as alpha. So the expression here, tan alpha is equal to, that is Q sine theta divided by P plus Q cos theta it would be. So Q is 25 into sine of theta is 30 degrees. Theta is 60 degrees. Let me correct it. Theta is 60 degrees whole divided by, this would be P is 50 plus 25 into cosine of 60 it is. So 25 into sine 60 is root 3 by 2, that is 12.5 times of root 3 divided by, this is 50 plus 25 is 25 by 2 is actually 62, so yeah, 12.5 plus 50, which is 62.5. So that is 12.5 divided by 62.5 into root 3 if we do, that is root 3 by 5. So tan inverse of root 3 by 5. So this is approximately equal to root 3 is 1.732. So 1.732 is 1.732 divided by 5, that is 0.34 it is, and tan inverse of 0.34 is actually 19 degrees. This is 19.106 degrees. So here the finding is that the angle alpha is 19.106 degrees. So here it clearly indicates that resultant will have the closeness to a force which is higher in the magnitude. The remaining angle comes out to be approximately 31 or 41, I suppose 41 or 40 point change it would be. So R is very closer to 50 newtons. Make sure you remember this point. The question states about a body resting on the horizontal plane requires a pull of 18 newtons inclined at 30 degrees to the plane just to move it. And it was found that 22 newtons inclined at 30 degrees to the plane just move the body. So here in the question, the nature of the force first is that a pull is being applied on 18 at an angle of 30 degrees, and a push of 22 newton at an angle of 30 degrees is applied. And for this situation, the weight of the block and the coefficient of friction is to be determined. So let me just draw the diagram. So herein, first is the 18 Newton of force is imposed on the block, making an angle of 30 degrees with the horizontal. This is 30 degrees, and let's say this is force P. So here P equal to, for the case 1, P is equal to 18 newtons. And same way in the next case, the force P will be taken as in the opposite sense. The same force, the force magnitude has been increased. Let's say P1 is equal to 22 newtons has been applied on the block at an angle of 30 degrees. So let's do the analysis. Here the block is going to have, if I start with the free body diagram, so first is the weight of the block that is going to act downwards, W, and there will be normal reaction which is going to be upwards, and along with that the friction force will also be accompanying. So friction force will be at the interface of the block and the ground, and it will be in horizontal direction. So this will be small f. So now here if we take up the equilibrium of forces, that is sigma fx is equal to 0, that is f minus p times of, it would be sine cosine of 30 degrees, that is equal to 0. So this is mu times of Rn minus P is 18 cos 30, this is equal to 0. So mu Rn is 18 cos 30, which is 9 root 3. Next is the forces in y direction, that is equal to 0. So Rn is upward plus the component of P that needs to be taken off. So P sine 30, Rn plus P sine 30 is equal to W. So here the value of Rn could be expressed as 9 root 3 by mu. So this is 9 root 3 by mu plus P is 18 sine 30, that is 1 by 2 into W. W is unknown. So here we get it as 9 root 3 by mu plus 9 is equal to W. Let's call this as equation number 1. Same way in the next case, you are finding that there will be weight W. So weight W will be the same, that is going to act downwards. Next is the Rn value, which is going to be vertically upwards, and the friction force is going to be opposite in sense. Let me just draw the friction force. So friction force will be opposing this. So this will be F, this will be W, and this would be Rn. So now in the case number 2, that is if we start with equilibrium of forces in the x direction, that is equal to 0, F minus P1 times of cos 30, that is equal to 0. So here we get it as mu times of Rn minus 20 into cos 30 is root 3 by 2 is equal to 0. So mu times of Rn is equal to 11 root 3, or Rn is basically equal to 11 root 3 by mu. Next is equilibrium of forces in the x direction. That is if we take up sigma fx fy is equal to 0. Next it would be Rn is upwards minus P, the force P will have the component in the downward direction, that is P sine 30, and W will be in the downward direction. So that is P1 sine 30 minus W is equal to 0. So we get here as W is equal to Rn plus minus P is 22. 22 into sine 30 is 1 by 2, that is 11. So W is equal to Rn minus 11, or else in place of Rn it can be expressed as W is equal to 11 root 3 by mu minus 11 it is. This would be equation number 2. Now if we equate the equation 1 and 2, that is 9 root 3 by mu plus 9 is equal to 11 root 3 by mu minus 11 it would be. So here if we take up the summation of the forces, so this is 9 plus 11, that is 20, is equal to, this is 9 minus 11, that is 2 root 3 by mu it would be. Next is mu is equal to, that is 20, 2 root 3 by 20, which is 0.71732 it is. Root 3 value is 1.732. 1.732 divided by 7 is 0.1732. That is mu. Now computing the value of W, that is W is equal to 11 root 3 divided by mu is 0.1732, or this could be also simplified as root 3 by 10 minus it would be 11. So root 3 and root 3 will get cancelled. So 11 into 10 is 110 minus 11, which is equal to 99 newtons. The question is about a weight of 1200 newtons that is being pulled up the inclined plane, whose angle of inclination is 25 degrees and coefficient of friction is 0.3 newtons. Let me just draw the inclined plane. So let's say this is the inclined plane. The angle made is 25 degrees, or let me write this as theta instead. Now the block is being placed on the inclined plane and this block is being pulled by a force. So the force first of all is applied parallel to the inclined plane, and in the second case the force has been applied parallel to the base. That means the force is horizontally imposed on the block. So let me draw the force. This is the force along the inclined plane. Let me call this as P. And in the second case, the same force has been applied parallel to the base. That is, force is being horizontal. Now, in both the cases, what is the value of P is to be determined. So first is that we start with the marking of forces. First is the weight that is going to act downwards. Weight will be acting vertically downwards. And the second is the components of weight that needs to be resolved along the plane and normal to the plane. So this would be the components of weight, and let me place it over here. One of them is along the plane and the other one is normal to the plane. So this will be theta, the angle included between the component normal to the plane and the weight is theta. So this becomes W sine theta and this would be W cos theta. And along with that, there will be another force that is going to be normal to the plane, that is normal reaction. So let me just draw that. This would be normal reaction. Let's call this as Rn. And along with this, there will be the friction force that is going to oppose. So the friction force will be opposing P. That is, friction force will be acting right downwards. So let me highlight the friction force separately. This would be the friction force that is going to act at the interface. So let's say this is F. Now, if we take the equilibrium of forces, that is in y direction, sigma Fy equal to 0, that is Rn minus W cos theta is equal to 0. So Rn will be equal to 1200 into cos 25 degrees it would be. Same way, next is sigma Fx is equal to 0. If we take, that is P is equal to, it would be the component of weight that is going to oppose W sine theta plus F is mu times of Rn. Friction force is mu times of Rn. So mu is zero point 0.3 into W cos theta it is. So this comes out as W is 1200. 1200 into a sine 25 plus zero point 0.3 times of cos 25 it is. Let me correct it over here. It's not 30, it's 25. Cos 25. So upon calculating these values, that is 1200 sine 25 plus zero point 0.3 into 1200 into cosine 25 will give us the value as, value of P would be 833 newtons. Same way, if we take the second case, here the same set of forces would be copied as it is. Nothing changed except the orientation of P. Friction force will be there. Next is the weight of the block. The components of the weight will also be reflected same way. The vertical force, that is W, will also be reflected. Next is the Rn, normal reaction, will also be reflected in the problem. Now here the change what we find is the P has to be resolved normal to the plane and along the plane. The P is required to be resolved normal to the plane and along the plane. So this is the component of P along the plane and normal to the plane. So this is theta, and this would be P cos theta, and the normal component would be P sine theta it is. So this would be W sine theta, this would be friction force W cos theta, and Rn will also be there. So in the situation 2, if we take the equilibrium of forces in the y direction, that is sigma Fy is equal to 0, that is Rn is equal to W cos theta plus P sine theta it is. So Rn is equal to W is 1200 into cos 25 plus P sine 25 it would be. This is the value of Rn. And same way, if we consider the equilibrium of forces in the x direction, that is W sine theta downward is taken as positive. Friction force is also taken as positive, and that is opposed by P cos theta, that is P cos 25 also could be written for this. So W is 1200 sine 25, and friction force is mu times of Rn. So friction force here, it is mu times of Rn, and instead of Rn we can write the entire force, that is mu is zero point 0.3 into Rn is 1200 cos 25 plus P sine 25 it is, and this is equal to P sine P cosine 25, P cosine 25 it would be. Now what we get it as, So the value of P will be equal to, that is 1200 sine 25 plus zero point 0.3 times of 1200 cos 25 whole divided by, so I can do one thing, I can take the P on the other side, and the expression becomes as P cos 25 from the right side minus zero point 0.3 sine 25 it would be. So this is whole divided with cos 25 minus zero point 0.3 times of sine 25. So the answer is approximately equal to 807 newtons. Explain the conditions of equilibrium for coplanar system of forces. Coplanar means all the forces are going to lie in the single plane itself. The forces could be meeting at a single point, that is, the forces could be coplanar or the forces could be coplanar non-concurrent. So here, let's try to understand. A coplanar system of forces is said to be in equilibrium when the body remains in rest or if it is moving with constant velocity under the action of forces. So, change in state of body is specified by the rate of change in the velocity, that is acceleration. So here, for the conditions of for the equilibrium, there should be three conditions that needs to be satisfied. That is, summation of forces in the x direction should be 0, summation of forces in y direction has to be 0, and the summation of moments should be equal to 0. So summation of forces in x direction says that no motion in the x direction, no motion in x and y direction, I can write it, and the summation of moments, if that is 0, then no rotation in the xy plane, no rotation in xy plane. So in order to understand this, let me just explain this to you with the help of simple body. Let's say this is an xy plane, and in this xy plane we have a body or a rectangular shaped body. So if this body is free to move in the x direction as well as it is free to move in the y direction, and it is going to rotate about the z axis, that is the axis normal to the plane, and this is the rotation in the xy plane. Okay, so now if I constrain this block, if I constrain the block such that it is not able to move in the x as well as in y direction, so I need to provide some pin. So when there is a pin introduced, the translation in x and translation in y is not there, and along with that, if instead of pin, if I am trying to clamp this inside some wall, or it has been clamped between the two jaws, then the rotation is going to be lost. So the conditions of equilibrium will be satisfied, that is, summation of forces in x direction and y direction will be 0, and the summation of moments will also be 0. Now if I extend this further, summation of forces in x and y, this would be 0 for coplanar concurrent forces, and if it is summation of forces is 0, forces in x direction is 0, in y direction if it is 0, and the movements even that is 0, this is applicable for coplanar non-concurrent forces. So if we take up a example for the case number 1, then the case number 1 is going to have the forces F1, F2, F3. So if I extend these forces F1, F2 and F3, they will be meeting at a common point and they are lying in XY plane. So for this case, the equation summation of forces in x direction and summation of forces in y direction is applicable. Now, in the second scenario, in the xy plane, if we are finding the forces F1 like this, parallel, F2 is horizontal, F3, let's say even that is also horizontal. So here the finding is that F2 and F3 will not be intersecting. Instead, they are parallel to each other. They are non-concurrent forces. So the non-concurrent forces will produce the couple, okay, and the rotation due to these non-concurrent forces should not be happening, and for that to not happen, the summation of moments should be equal to 0. And since the translation in x and translation in y, that is motion in along x and motion in along y, that is also made 0, then only the body will be in rest. So translation should not be permitted, that is in x and y, x as well as in y, and rotation also is not to be permitted. State the parallelogram law of forces and write the expression for magnitude and direction of resultant force. And the second one is state the Varignon's principle. So first question, if we observe, the two forces that are acting simultaneously on a particle and are represented by magnitude and direction as adjacent sides of the parallelogram. Let's say this is one force P and the other force would be Q. So let's say Q is smaller, and let me just orient this. So this will be the force Q. The resultant force is going to act from the same point, and it is going to be represented as the diagonal of the parallelogram. So this would be the resultant force, and let me just extend it. So this is force Q. Let me place it over here. This is vector P, and the R will be something like this. This is where the R is going to be, and this was the vector P. So here we find that the parallelogram is being closed by using these vectors. So this is vector P, same way there will be vector Q, and this will be vector R. Let's say the angle between P and Q is theta, and the angle between R and P is alpha. So the expression comes out as R is equal to P square plus Q square plus 2PQ times of cosine theta under root. Next is tan alpha, that is equal to Q sine theta divided by P plus Q cos theta it would be. Next answer we have is Varignon's principle. The moment of resultant about any point, it is equal to algebraic sum of moments of all the components of forces about the same point. So to explain that statement, let's say this is the coordinate system, and in this coordinate system, let's say this is the point O, that is origin, and there is a force F that is acting in the plane xy. Let's say this is the force F, and the perpendicular distance of F from point O, let me just draw the F, and let me draw the perpendicular distance of this force from the point O. So the perpendicular distance, for that I need to rotate it by 90 degrees, and it has to pass through point O. This would be the perpendicular distance. Let me change the color. This is perpendicular distance. So let's call this distance as A. So moment can be expressed as moments about O is equal to F into OA. Next is, what I do is I'll resolve this force into the components along x and y directions. So let's say this is the axis. Now this would be horizontal component. Let's say that this is theta. This would be f cos theta, and the vertical component is f sine theta. Now the perpendicular distances from the x-axis and y-axis needs to be measured. So let's say that f sine theta is measuring a perpendicular distance of x and f cos theta is measuring a perpendicular distance of y. So this could be in fourth quadrant. For that reason y would be negative, but here we are strictly taking that as a distance. We are not specific to the quadrant. So with respect to point O, the x component and y component will produce a counterclockwise moment. About O, if you observe, this is producing a counterclockwise moment. The arrow is being directed upwards. Same way, about point O, f sine theta will produce counterclockwise and f cos theta also produces counterclockwise. So for that reason, from f sine theta, you need to draw a perpendicular from O. So if you observe the force and perpendicular distance, and if we try to rotate it about O, it is producing counterclockwise. And similarly, f sine theta, f cos theta, if we talk about that, so point O is above and f cos theta is below. And if I extend that perpendicular distance and if I keep the arrow or try to rotate it, or it is going to basically cause the rotation in counterclockwise. So same is the effect. So individual force is replaced with the components in Cartesian coordinates. So that is f sine theta into x, that is one component of that force. Next is f cos theta into y. So either you take f as a single force and multiply that with the perpendicular distance, or the f has been split into two components and the moment of each component will give the collective effect. Summation of the moment of each components. When you sum up these component moments, it will give the collective effect that is being produced by the f. That is the Varignon's principle. If this session made engineering mechanics easier for you, hit the like button, comment your doubts, share it with your friends, subscribe for more high quality engineering tutorials every week. Your support helps the channel grow and reach more students.